Okay, so the voice is clear, and again, you are able to see over there, isn't it?
You are cutting.
Still cutting, guys. Is it still bad for everyone? Reyes, who else is Prudence? Guys, am I still cutting?
Okay, it's
Much
fine now.
better
It's
than
fine.
before, sir.
Fine now,
Much-
sir.
Yeah, it's fine now.
Okay, 100%. So
Yeah, it's better now, Mynheer.
which part did you guys miss? I'm not really sure of when
When
it
you were talking
started
about
breaking.
that exercise, that activity.
Okay, so I'll quickly talk about this before we move on to the rules. I wanted to say all of this may look a bit complicated or difficult to approach or to solve or to simplify. But based on today's lesson, I'm hoping to teach you all those rules and how to apply them in order for you to be able to approach and solve this type of problems. So what I like about this type of lessons is because you have an opportunity to see exactly where you are heading. So that means by the end of this lesson, everyone, each one of you, should either understand how to solve this type of problems, or otherwise, if you spend much of your time practicing, you should be able to approach this type of questions on your own. And again, what I wanted to add to that was that as soon as we are done with this lesson, I'm going to post in the group exam-related questions which you can use to practice. So, ladies and gentlemen, let's now proceed with the maths basic rules. So, otherwise, the rules or exponential laws. So, before I proceed, guys, are you able to hear me? Is everything clear so far?
We are able to hear you, sir.
Okay, 100%. So now, I
Yes,
hope
sir.
you understood that part. I'm not really sure if you were able to punch all of that I had written over there and check if it gives you the same answer. But I think it does, because I've done more of this and I've also tested them on my side. So let's consider this as the third rule, or rule or law number 3, which is a to the exponent m close to the exponent n. Okay, so what does that mean, ladies and gentlemen? It means when you've got a base and an exponent within the brackets, then you just multiply the exponents. So that means the whole of this is the same as we've got the same base, you just multiply the exponents, which means you've got m multiplied by n. So in one of my grade 10 lessons, I've explained how to use this signs, guys. I think it's worth redoing that mini lesson. So we know when we've got BODMAS, ladies and gentlemen, let me just start it from the beginning to say BODMAS, we know B is for brackets. And
So you're
then
starting to cut again.
is it still bad for everyone? Because I've noticed even before I started this lesson that the network is a bit poor. But just in case, for every time when I break, just let me know so that I don't go for too long, whereas all of you guys cannot be able to hear. How is it now? Is it better, or is it still breaking? Someone to confirm?
No, sir, it's fine now, sir.
Okay, so let me continue now. So remember, guys, that O, it refers to the order, but there's a lesson, a very special lesson, where I replace that O with I, which is what I call a index.
They're
So the whole
breaking
of
right
this,
now.
Let me also try to check who else is. Mr. D, am I also breaking from your side? There's Thea, there's Ria. Because I also want to try and check if the network is poor on my side, or otherwise you might find that wherever you are, maybe the connection is a bit poor.
It's
Someone
still
to confirm for
breaking.
me. Mr. D, am I breaking from your side? Let me see who's see.
Yeah. It's better now. It's better now.
It's better, ne? See on your
Yeah.
side, how is it? Who else? Prudence, Lerato, Nielin. Guys, am I still breaking on your side?
It keeps breaking and getting better. Like,
Yeah, no, I see. Sure. I wonder what could be the issue. But one thing for sure, I did notice that today's network is a bit poor. So let me see. So how
But
is
you
it now?
can
Is it?
carry on.
I can let me
Just
just
carry on. We'll
try
tell you if
to
there
get
is a
on. Yeah.
problem.
No, in case
Yeah.
if it does, then just keep on notifying me. Otherwise, if need be, for today's lesson, we can just concentrate on the exponents, the exponential laws. But otherwise, let's just try to push until we get to the end. So, guys, I was saying that O simply refers to the order, or otherwise that I, it refers to an index. An index is that term with a base and an exponent. So, what I want to emphasize is these two: division and multiplication. So division can be that sign, it can be that over where you've got a numerator and a denominator, or otherwise you can have that slash where you've got a number there, just like maybe 1/2 can be written as 1/2. So when it comes to a multiplication sign, you've got that sign, you've got a dot, and again, you've got nothing. So for multiplication sign, it can be represented as that multiplication sign or a dot, or otherwise just nothing. I want you guys to notice something very much important. So when you multiply a number by a number, you use that sign. For example, 2 multiplied by 2, you use that sign. You cannot use a dot or nothing in between the numbers that you are multiplying. For example, let's see what happens when we use a dot. It's going to be 2.2, which seems as if it's 2,2. And again, you cannot just use nothing as a multiplication because it's 2 times 2, which seems to be as if it's 22. So you will realize something, guys. When are you using a dot as a multiplication? So if you're multiplying a number, not even a number, guys, but let me use a, what is it? I think let me use a letter and say when you multiply, let's say B dot a Y. When you multiply letters, that's when you can use a dot in between. So why not using that multiplication sign? So in mathematics, normally they like using letter X. So imagine having to multiply X by X, with a lot of us having different types of handwritings. Some of us, we just write X like that, some write it that way. So imagine for those who are writing X like that, it's going to be X multiplied by X. Can you see? Which seems as if this is 3x's, which is like x to the exponent 3. So now, when do you use just nothing? That's when you multiply a number and a letter. For example, 2y. Guys, very much important for you to notice that there's a multiplication sign in between. So you can still say 2 dot x. We know this is 2x, but avoid using 2 times x, because it seems as if you've got 2xx. So, ladies and gentlemen, I'm not really sure if that makes sense, but you will notice the importance of what I've explained just now, especially when we deal with related problems, because you'll be able to identify a term which is being multiplied or added. So, guys, as we continue with that rule, remember, guys, remember, m multiplied by m, it's still the same as a to the exponent m dot n. Can you see now with that multiplication sign over there, which is what I was trying to explain? With someone's different handwriting, it may seem to be a to the exponent m x n. Can you see? So that is why preferably when you multiply the letters, use a dot in between. But what I've just explained has got nothing to do with that law. So again, what I want you to notice, guys, is that a to the exponent starting with n is still the same as a m multiplied by n. It's still the same as n multiplied by m. It's more like 2 multiplied by 5. This is still the same as 5 multiplied by 2. You just swapped those numbers. So now, what format can we use to write this type of problems or situation where you're multiplying the letters? The best thing to do, that's what I advise most of my learners to say, guys, use alphabetical order. So you know you've got A, B, C, D, all the way up to Z. So when you multiply the letters, guys, write them in alphabetical order. You will see when you get to that stage of maybe solve for x or simultaneous equations, where you might be having 2xy. Let's say this is minus 7yx. If you do not get used to writing the letters in alphabetical order, you won't notice that these are actually like terms, whereby you just need to write everything in alphabetical order. So obviously we know x comes first, followed by y. Minus 7. Then you rearrange those two letters to say this is x multiplied by y. So now you can see you've got the like terms which are clear, and this is the same as 5xy. So guys, before I give an example of that law, up to this point, was everything clear? Were you guys able to clearly hear when I speak, or was it breaking?
We were able to hear, sir.
Okay, 100%. So let's now confidently move on. So let's try to have a look at an example related to this where you can apply that law. So let's say in brackets, you've got 3x to the exponent 4, you've got y to the exponent 3 close squared. So ladies and gentlemen, in this case, out of all of these three laws, which law can you apply to simplify this? Obviously, this is the law that you can apply. So how do you then apply this law? Remember, guys, you've got the whole of that inside the brackets, and you've got an exponent over there, which means that exponent multiplies all the exponents of everything within the brackets. Remember, you've got that invisible one over there, which means it starts multiplying there, and again it multiplies that, and again it multiplies that. What if you had p, let's say pq in brackets, you had 4 over there. Remember, there's that invisible 1 over there. It also has an exponent of 1. So even though if you say 1 multiplied by 4, so that means 1 to the exponent, let's say 1 multiplied by 4. This is still the same as 1. So that is why for this type of a calculation, there's no need for us to say 1 to the exponent 1 multiplied by 4 multiplied by p. We know there's 1 there, multiplied by that same exponents. We know there's 1 there, multiplied by q to the exponent 1 multiplied by 4. We already know the whole of this is still the same as 1. But if it's 2, 3, 4, or maybe 1.1, or maybe 1.5, that's when you need to show that 1 over 2, then the whole of that. When you say 1 multiplied by 4, it's not 1 because of that base, it's not 1. So it's a special case where when you've got 1, then you can just ignore that. What I'm trying to explain is that in this case, we've got the coefficient as 3, which means you are forced to say 3 to the exponent 1 multiplied by 2. Remember, this is where you can use a dot in between because you're multiplying a letter and a number. Or otherwise, if you've got letter times letter, you can use a dot. This is where you can avoid using a multiplication sign. So guys, we've got x. What is the exponent of x? It's 4. You multiply it by that same exponent. Dot y to the exponent is 3. You multiply by that same exponent. So ladies and gentlemen, it doesn't end there. You need to further simplify the whole of that by working out the exponents. So it's more like, obviously, 1 times 2 is 2, which means you've got 3 squared, multiplied by that to the exponent that, it's x to the exponent 8. We know 4 times 2, it's 8. Multiplied by y to the exponent 3 multiplied by 2, that is 6. Ladies and gentlemen, it doesn't end there. Ask yourself these questions. Can you further simplify that? Can you further simplify that? Can you further simplify that? It seems like these two you cannot further simplify. They are in their simplest form, but that you can simplify it or write it as just a single number, which is a 9. Then anything else remains the same. Can you see? You've got that choice to either write a dot over there or not make a dot at all. Guys, up to this point, did everyone understand how that rule operates before I remove the whole of this and move to the next law? Or otherwise, yeah, no, that was an example of the application of that law. So do you guys understand? Did you understand? Was everything clear up to this point?
Yes, sir.
Okay,
Yes, sir.
100%. So now I'm going to
Yes.
get to law number 4. Let me just try to get another marker. Okay, so law number 4 says if you've got a multiplied by b close, then this is to the exponent, let's say m. This is almost the same as the law above, ladies and gentlemen. You know, when you've got something inside the brackets and you've got that exponent over there, it means you multiply the exponents of whatever that is inside the brackets. So which means this should be the same as, obviously we know there's that invisible 1 over there and there. So it's more like it's 1 times m dot b 1 times m, which is the same as a to the exponent m dot b to the exponent m. So now let's try to find an example where we apply that rule. I think the rule that we've actually, the previous example that I've made, I think it actually addresses this rule. And for that rule, it was actually supposed to be something very simple. So I'm just impressed that you understood, even though I had to just use a very simple example for that rule over there. So obviously, if we apply that rule number 3, this is 4 to the exponent 3 multiplied by 2, which is still the same as 4 to the exponent that times that, it's 6. So both of these laws, they are almost the same, guys. There's no difference over there. Well, the difference could be that you've got a number there and a number there, which are different numbers. For example, it could be 2 multiplied by, let's say, 7 over there inside the brackets, then you've got exponent 3. So the only difference is that here you've got one base, but there you've got 2 different bases. But otherwise, the approach is the same. You just know you have to multiply the exponents of whatever that is inside the brackets. So, ladies and gentlemen, I hope that too also makes sense. So now I'm going to move to law number 5. So let's see. Law number 5, let's say we've got A over B, the whole of that to the exponent m. Ladies and gentlemen, nothing complicated here also. You still have to multiply the exponents of the numerator and the denominator, which means this should be the same as a to the exponent 1 multiplied by m over b to the exponent 1 multiplied by m, which is the same as a to the exponent m over b to the exponent m. Someone might be saying, why are we not having the same base and subtract the exponents? Remember, the bases are not the same. You cannot apply that rule. So you cannot use this rule to apply one of the rules above. So the bases are not the same, then it means you just leave it as it is over there. So let's check if we can maybe have an example. Let's say we've got a 4 over, let's say, x squared over there, and this is to the exponent that, which is 3. So based on that law, it means you must multiply the exponents of the numerator and the denominator by 3, which means we are going to have 4. We know there's an invisible 1 over there, which is 1 multiplied by 3 divided by x to the exponent 2 multiplied by the same exponent, which is 3. Therefore, it means this is 4 to the exponent 3 over x to the exponent that, you know, it's 6. So you can further simplify that because you can punch it on a calculator, which is, I think it's, 64 divided by x to the exponent 6. Ladies and gentlemen, I'm not sure if you fully understood this laws from law number 1 all the way up to law number 5. Up to so far, did everything make sense, guys?
Yes, sir.
Second confirmation?
Yes,
Yes,
sir.
sir.
100%. So now, remember, guys, don't worry that much about writing as I write all of this. I'm recording this lesson and I'm going to make it available for everyone to catch up at a later stage. So for now, you can just listen as I speak, and again, just make sure that you fully understand. Otherwise, if you've got some additional questions while using this lesson to catch up, that's when you can communicate on my upcoming lessons. So guys, now I want us to have a look at exponential definitions. These definitions, ladies and gentlemen, are what we all need to be aware of, because in most cases you need to apply these definitions. For example, let's say we've got a to the exponent
Yeah,
0, guys.
breaking.
So it's breaking again. Is it breaking for everyone?
No,
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 sir,
sir.
it's still on my side.
Okay. So remember, just in case if it happens that it breaks for some time and you missed some of the information, I'll just continue with the hope that you will watch this lesson just to catch up. But otherwise, if it breaks for everyone, I will still need to end the lesson and start it again immediately. So guys, a to the exponent 0. This is equals to 1. I always say, and I've always been saying this in my lessons, I've been saying anything, even on yesterday's lesson, to the exponent 0, it's equals to 1. What is anything? Anything, it could be any letter which is A up to Z. For as long as it's to the exponent 0, this is equals to 1. Which means if you punch on a calculator 4 to the exponent 1, 0, it should be 1. If you punch 7 to the exponent 0, it should give you 1. Let me check if you punch 0 to the exponent 0. I'll check if I get 1, and again, if I punch a negative number and say to the exponent 0, I'll check again if it gives me 1. Then if it does, it means anything to the exponent 0 is 1. To the exponent 0, I'm getting error. So with 0, I'm getting an error. So let me try to check when I use a negative number. So I can say maybe negative 10, it's equals to, I'm getting a, what is it? I'm getting 1. So that means when I say anything to the exponent 0, then I have to say that is provided anything is not equals to 0. So it's more like I'm making a rule to say anything to the exponent 0 is equals to 1, but not 0 to the exponent 0. That is why I'm saying where anything is not equals to 0. So guys, all that I've explained, do not worry that much about all of that. You just need to be aware that when you've got a number to the exponent 0, it's equals to 1, but that number should not be 0. An example, let's say 3 to the exponent 0, I've explained it's equals to 1. So I hope that part, ladies and gentlemen, it makes sense. Remember, in case if there's something you don't understand, you are welcome to quickly pose your question. But most importantly, firstly mention your name. So now the second rule, it says 1, or the second definition, not a rule, 1 to the exponent a is equals to 1, where or otherwise we can say with a being the element of real numbers. So it remains your homework to find out what are the real numbers. So let's try to check an example. Let's say 1 to the exponent 4. Punch on a calculator if this is going to give you 1. Punch 1 to the exponent let's say 10. Check if it's giving you 1. Punch on a calculator 10 to the exponent 90 and check if it gives you 1. So when you practice, guys, you must be curious to say, what if I punch 1 to the exponent negative 2? Will it give me 1? What if I punch 1 to the exponent 0? Will it give me 1? What if I punch 1 to the exponent negative 1 over 4? Will it give me 1? So when you practice, guys, do not just say because this is what it is, then you just don't explore other possible factors. Just try to play around and check if you're getting a 1. Let's say with negative 2, you're getting 1. And then let's check again with negative 1 over 4, I'm still getting 1. What if I punch with 0? So I'm still getting a 1. Which means now that when we punch with almost everything, we get 1. What does it mean when they say with a being that exponent is the element of real number, which is something that I'm giving you as a homework to find out. So ladies and gentlemen, let's now move to the next or the third definition, where if you've got x to the exponent negative n, guys, this is the same as 1 over x to the exponent n. So for me, in order to understand this rule, it's more like I want to write the whole of that as a positive exponent. Can you see there? We've got a negative exponent, but I want to write it in a positive exponent. Remember, you can be given something similar to that in a positive exponent, and you can write it in that manner. It all depends on what the question wants you to do. So that's why after doing all of these rules, we should take 1 or 2 examples to see if we can apply the rules and these definitions. So why 1 there and not a different number or whatever? Ladies and gentlemen, that 1 comes from that invisible 1 over there. You see, so this is where that 1 comes from, which means if we had 2, let's say p to the exponent minus c, then it was going to be 2 over p to the exponent positive c. Can you see? I just want to rewrite that exponent as a positive and not a negative exponent. So guys, let me quickly try to check if I can find a relevant example. Let's say I've got what is it, 4? No, x to the exponent negative 4. Based on my explanation, at the top or in the numerator position, you've got 1, which is that 1 over there divided by x to the exponent 4. Ladies and gentlemen, up to this point, are we all on the same page? Is it not breaking? Is everything clear, guys?
Everything is clear, sir.
Yes, sir.
Everything is clear.
100%. Let's now move to definition number 4, which is what I've just explained to say. Let's say we've got ax negative n. This should be the same as, what is it? Obviously, that is the coefficient, which could be 1. In that case, it was 1. I've just explained that it could be any letter, but you write it there as the numerator. You've got x to the exponent positive n. So this is what I've explained, guys. An example, it could be 3 x to the exponent negative 4. Obviously, this is 3 over x to the exponent positive 4. So guys, I hope you fully understand all of that. Remember, guys, this is our goal. This is our goal. I want you to realize that if I hide, let's say, all of that, you just remain with 4 to the exponent n plus 2. If I hide that and leave that, it's 9 to the exponent that. So this type of problems, they may look a bit complicated, but it's just a combination of all of these rules, of which it's very, very much important that you learn each of these rules. Because if you miss just one rule or you don't understand one of the rules, you wouldn't be able to solve or simplify the whole of that. Same applies there, ladies and gentlemen. You know, if I hide all of that, this is one of the rules that I've already explained. You can expand all of that and do whatever that is possible. But because in this case, you might find that they want you to solve for x, then there's a different approach that you apply to this type of problems, but applying those same rules. So that is our goal, ladies and gentlemen. By the end of this lesson, we should be able to easily approach or solve those type of problems. So now let's move to rule or definition number 5. Let's see. We've got a multiplying x to the exponent negative n. What an interesting problem, guys. So remember, guys, for the fact that you've got a negative exponent over there, it doesn't matter whatever that is inside the brackets. In this case, you are only interested in having a positive exponent, which means we've got a coefficient over there, which is 1. So that's why you're going to have 1 over the whole of that, just like you did with x over there, the whole of that, just like you did with x over there, the whole of that. In this case, we've got a being multiplied by x to the exponent positive n. I hope it makes sense, guys. Someone might be wondering, why are we not multiplying the exponents? You can still do that. Let's see. If you multiply the exponents, it means you're going to have a to the exponent negative n multiplied by a, no, in that case, it's x. X multiplied by a, obviously the exponent is 1, 1, so it's just negative n. So to get to that, you obviously know there's a coefficient of that invisible 1 over there, which is what you're going to write as 1 over, you write that as a positive, then it's a to the exponent positive n multiplied by x to the positive n. So someone might be saying, this does not look like that one. It does, because that one, we just didn't multiply or remove those brackets. But when you do, you've got that one, and then you multiply the exponents, which is a to the exponent n, then it's x to the exponent n, which is the same as that. Someone might be saying there's a dot in between. Remember, guys, I've indicated you can have a multiplication as that sign or a dot or just nothing. In this case, I've got nothing, but it's still multiplying this two. So which means I can decide to have a dot or not have a dot. So that is why it's very, very much important, ladies and gentlemen, that you understand how a problem is represented. So you cannot be frustrated when you see a dot and somewhere you don't see a dot. It refers to the same thing. So let me try to get an example. Let's say we've got 3x, the whole of that to the exponent that. Remember, guys, we've got an invisible 1 over there, which is that 1 over the whole of that to the exponent positive 4. We can further simplify this thing, even though for that rule, you can just end it there. But how can we further simplify that? We multiply the exponents, which means we've got 1 to the 3 to the exponent 4 multiplied by x to the exponent 4. Then you can say 1 times the whole of that, whatever that it is, multiplied by x to the exponent 4. Then it ends there. So guys, before I move to the next definition, did that part make a complete sense?
Yes, sir.
The next person to
Yes,
confirm,
sir.
100%. So now we can have 1 over x to the exponent negative something. So in this case, how do we work out this one? So now we've got a negative exponent. Remember, what we've been doing there, it was actually to rewrite the whole of that with a positive exponent, which means we don't want to be having something with a negative exponent. So let's rewrite that one. It's almost as if we're doing a reverse of what we've been discussing or doing over there, which means in this case, you are going to have that 1 over there, which is that 1, multiplied by x to the exponent positive n. So you no longer have that fraction over there. So this is the same as just x to the exponent n. So let's try to find an example. Let's say we've got 1 over x to the exponent negative 4. So according to that, it means you're going to have 1 multiplied by x to the exponent positive 4, which is the same as just x to the exponent 4. So that invisible 1 over there, it's not really necessary for you to write. So guys, it took me some time to understand why it's not necessary to write that 1 over there. I've been asking my teacher to say, if it's 1, why are we not writing 1? Because when it's 2, we write 2. So exactly what I'm going to say is what my teacher said to me. He said, Desmond, if batswadi ba hao ba o roma o reka something at the shop, then you come across a goat, and then ho bua ba o botša gore o tlhakane leng, you wouldn't say ke tlhakane le podi e tee. Or otherwise, if o tlhakane le motho o mo one, you wouldn't say ke tlhakane le one motho or one person. You will just say I met one person. Otherwise, if it's more than one, that's when there's a need for you to specify to say I met 2 guys or 3 guys or 4 guys. But if it's just one, there's no need for you to say I met one person. You just say I met a person. So that's when I realized that there's no need to write an invisible 1 because it doesn't change anything. Whether you say I met one person or I met a person, it doesn't really change or affect your response. So guys, before I move to number 7, I'm not sure if you fully understand that part. Can someone try to make an indication on that one?
We understand. Sir.
Okay, 100%. So now let me remove all of that and get to definition number 7. So guys, these are the definitions. So let's say we've got a over what is it? Over, let me check on my nose, x to the exponent minus n. So this is still the same, guys. It's still the same, where we need to write that as a positive. So we're going to have a, which is that a, just like we had 1 over there, multiplied by x to the exponent positive n. So obviously, guys, that one, it's also straightforward. Let's say we've got 3 over what is it? Let's say maybe to the exponent minus 4. So this is going to be 3 multiplied by x to the exponent positive 4. So that definition, guys, it's straightforward. Nothing complicated on that one. So number 8, let's see. If we've got 1 over x to the exponent negative n. This is an interesting one, ladies and gentlemen. This one is an interesting one. Let's check. What exactly are we trying to achieve out of this? Remember, we just want to write a positive exponent. So obviously 1 has got a positive exponent. A has got a positive exponent. So we just move that letter with a negative exponent, which means this is going to be x to the exponent positive n over a, because the exponent of a is already a positive number. But remember, that one over there, it's still there, which is that invisible one. So guys, I hope this one, it doesn't confuse you. So an example, let's say we've got 1 over let's say 3x to the exponent negative 4. It means you are going to move only that with a negative exponent, which means you are going to have that one multiplied by x to the exponent 4 over 3. Guys, I'm not sure if that number 8 makes sense for everyone. Do you understand what I'm trying to explain to you guys?
So can you please
Yes.
explain it again? I don't understand.
Okay, 100%. What am I going to do now? Let me not erase all of that, but just write here. I'll see if what I'm trying to do is going to work. Okay, so number 9. We're now on number 9. So on number 9, let's say we've got a over b, the whole of that, to the exponent negative n. So what about that? What about that one? So guys, on this one, the rule says this is the same as b over a to the exponent positive n. So it's more like when you've got a fraction within the brackets and you've got a negative exponent, then you just swap the denominator and the numerator and have a positive exponent. So because our understanding, or the level of our understanding, it's not the same, you need this type of lessons where we go deep into explaining why or how come do we swap the denominator and the numerator. Remember, based on those laws that we did, that can multiply the exponent of each numerator and the denominator. Let's just try to work it out. Let's say you're going to have a to the exponent negative n over b, in this case to the exponent negative n. So this is the same. I'm just trying to get it to there. Remember, guys, we want to write a positive exponent, which means if I want to work out that part alone, I'm going to leave that invisible one at the top and say over here there was that b to the exponent negative n. So now I'm bringing that to the bottom. It becomes a to the exponent positive n. So now can you see I still have that b with a negative exponent. So you are going to do the same just like we did with the previous definition, where we move it from the bottom to the top just so that we can have a positive exponent, which means you are going to have b with a positive exponent over a with a positive exponent. Can you see? Now that you've got common exponents, you can simply write that as b over a to the exponent n, because you know that n is for both a, b, and a. So guys, I'm not sure if it now makes sense, that rule with that explanation. Any one of you to confirm before I move to the last definition? It's not even the last. There are two more. But otherwise, did that make sense, guys?
Yes, sir.
Yes, sir.
Okay, 100%. So this was actually supposed to be definition number 10. So we were supposed to have done definition number 1, of which if you understood that one, you will understand number 9. It's a multiplied by x, the whole of that to the exponent negative n. So obviously, guys, you can see we've got a negative exponent there. So we just move everything to the top, which is going to be that one over there multiplied by the whole of that to the exponent positive n, which is an easy and a straightforward definition. So now let's get to number 11. So number 11 says when you've got a to the exponent negative m over b to the exponent what is it, negative n. I've just explained this one indirectly, guys. I've explained it when I was doing that number 10, of which you will easily understand. Obviously, this is where you can swap. You want to have that as a positive exponent. So if you don't want to do them simultaneously, you can just write that as it is and only say you have moved that one at the bottom to rewrite it as a positive exponent. So you've got that you still need to change to a positive exponent, which means you are going to have b to the exponent n and you move that to the bottom with a positive exponent. So ladies and gentlemen, I hope the whole of what I've explained from the beginning of this lesson up to now, it made sense. So now, can we try to work out those problems that I've indicated to you? Before I start, is there any one of you guys who's got a question so far? So it means no question, isn't it?
No questions, sir.
Okay, so I'm going to remove all of this. I'm going to remove all of this and bring that first problem over there. So let's have a look at that problem. I'm just going to quickly rewrite it as it is. So number 1, we've got let me try a different marker. Let's use that one to say we've got 4 to the exponent n plus 2 multiplied by what is it, 9 minus 1. The whole of that is 72 to the exponent n multiplied by 2 to the exponent 1 minus minus n. Shreyas, are you still there? Can you unmute your mic?
Yes, I'm still here.
So Shreyas, what is this?
So this is an exponent, sir.
Remember from our very, very first lesson where I taught you how to identify the type of a problem that you're dealing with, either an equation or an expression. Expression. So my question to you, Shreyas, what is this?
An expression, sir.
Why are you saying it's an expression?
Because there's no equal sign, sir.
What does it mean when you've got an expression and you don't have an equal sign?
simplify.
So, ladies and gentlemen, Shreyas is a grade 10 learner together with Mr. Tel. I'm not sure if he's there on this lesson, but I had to teach them how to identify the type of a problem that you are facing. I'm going to quickly explain using this. So, number one, this is what we call an expression. Why are we saying it's an expression? It's because we do not see an equal sign. If it's an expression, what do we do, guys? We simplify. What does it mean when we simplify? It means we just have to rewrite the whole of this in its simplest form. That's it. So that means in the end, whatever that you write, it should still represent the whole of that. So it's more like they give you something which is complicated or which is long, and you just have to shorten it. How do you shorten it? You use those exponential laws or those exponential definitions or rules. So, ladies and gentlemen, number two, Shreyas, what is number two? What problem is that?
So this is an equation. We
Why
have
are you saying
to,
this is an equation?
because of the equal sign, and we have to solve for the unknown, which is x.
So, which means, ladies and gentlemen, if this is an equation, because of that equal sign, it means we must solve for the unknown. What is the unknown? The unknown is any letter from A up to Z. So in this case, our unknown is X. Then it means we must solve for X, which means in the end, we must say X is equals to something. Do not give anything else other than X is equals to something as your final answer for this problem. Similarly, there, because of that equal sign, it means the whole of this, it's an equation. But remember, we've got different types of equations. So you've got a quadratic equation, you've got a linear equation, you've got a quadratic inequality. So if you've been attending my lessons from the beginning, you will be able to differentiate between a linear equation, a quadratic equation, and again, a quadratic inequality. So that's why I'm saying do not underestimate my grade 10 lessons, because that's where I teach the basics. Without you being able to identify or understand the type of a problem that you're dealing with, you won't confidently provide the final answer. It's more like you are given a case study at school as your project, your assignment, or whatever. If you are not able to identify the main problem, if you're not able to interpret the problem, you won't easily be able to provide an answer or a response to a question. So in high school, and let me just say in high school, they teach you how to solve this type of problems. When you get to tertiary, they teach you to equate or derive equations where you solve a problem. When you get to the workplace, they just give you a problem. So it's a client telling you that I've got this problem. So you need to think deep and analyze the problem in order to provide a solution to your client's problem. So that is why it's very, very much important that even when you are in grade 12, do grade 10 stuff, do grade 11 stuff. I always say I did my grade 12 in grade 12, and again I did my grade 10 in grade 12. I also did my grade 11. I did almost all the grades in grade 12 because I went to grade 12 without solid basics. So I had to learn those in order for me to get distinctions in major subjects. So ladies and gentlemen, let's have a look at our problem for today. So that 4, can you guys help me with that 4? Which other way can I write that 4? Do you agree with me if I say that 4? I can write it as 2 squared. Do you guys agree?
Yes, sir.
Obviously, the exponent there is n plus 2. So can you see, I've tried to do a bit of simplification for just that part. Then I move on to the next, which is that one. 9, ladies and gentlemen, I think 9 is 3 squared. So just rewrite it as 3 squared. It's more like we want to write that with its smallest base. So this is to the exponent n minus 1. You are done with that part of simplification. Now move to that part at the bottom, ladies and gentlemen. At the bottom, let me just say over. At the bottom, we've got 72. Which other way can I write 72, ladies and gentlemen? Is there someone who wants to guess how can I write 72 where I've got a base or basis and exponent or exponents?
It's going to be 2 cubed times 3 squared.
Guys, massively important. She's saying it's going to be what? Is it 2 cubed?
Yes, sir.
So before you get to 2 cubed, so that someone understands, this is how you can do it, guys. This is how you can do it. You can just run a test to say 72, let's say divided by 5, it gives you a fraction. I just started from 5. You can start from 1, and then you say 6, you get 12. Then you say, can you say square root of 6 and it gives you something? What do we call it? Is it a perfect square? Or what do we call those things? Can someone assist? Something like 9, is it a perfect square? What do you call it?
Yes, sir. It's perfect square.
So that means you are going to divide 72 until you get 2 perfect squares. So that means Lerato said 72 divided by, where am I, 7. She's no longer using 237 because she knows she can just start from 4. It's a perfect square. From 4 was the next perfect square. Maybe, okay, let's check with 9. Divided by 9, we are getting we have 8 and 9, which means we can use 8 times 9. So 8 is the same as, what is it? It's 2 cubed, as she said. Multiplied by 9 is 3 squared. So I just wanted you guys to understand where that 2 cubed and 3 squared comes from. So that means we've got 3 squared multiplied by 2 cubed to the exponent n over there, multiplied by. So now you've got that base which is in its simplest form. Nothing much can be done over there. So guys, this is what I wanted you guys to notice. Remember, you can separately do that, separately work out that, separately work out that, separately work out that, using those basic rules that I've indicated in the beginning of the lesson, guys. So now they just combined everything and they want you to work it out as it is given. But you just do that, you do that, you do that, you do that. So now let's apply those rules. Remember, guys, I think let me quickly rewrite this so that everything is going to fit there. So quickly, if I was in exam, I was going to say 2 squared n plus 2 over there. This one I know is 3 squared to the exponent n minus 1. This one is 3 squared multiplied by 2 cubed to the exponent n to that. So, ladies and gentlemen, now we need to remove the brackets. Obviously, you can apply that rule where you multiply the exponent, which means you're going to have 2 multiplied by that, 2 multiplied by that, which means you've got 2 to the exponent 2n plus, obviously 2 multiplied by 2 is 4. Multiplied by, you do the same also for that, which is 3 to the exponent 2n minus a 2. The whole of that divided by, you do the same, you know that rule, that times that times that, which means you've got 3 to the exponent 2n multiplied by 2 to the exponent 3n multiplied by 2 to the exponent 1 minus n. So guys, did all of that make sense? Even though I did not tell you exactly which rule you apply, but obviously you still remember those rules. Did all of that make sense, guys?
Yes.
Yes,
Yes,
sir.
sir.
100%. So now, what is the next step? So ladies and gentlemen, remember, this is an expression and we're trying to simplify. So normally when you're given an expression, some parts of whatever that you're given will cancel each other out, which is why you might need to expand all of this that you are given. Remember, a to the exponent m plus n. This is the same as a to the exponent m multiplied by a to the exponent n. So can you see? You can use this rule to save yourself. So they can either give you in that form or in that form, and you need to just play around that law. It's actually a law. So that means it's given in this form. That one over there, same as that one over there. This one is already worked out, and again, that one over there is given in that form. It doesn't matter there whether it's a positive or a if on the given equation it's a negative. But what you know is that same base you add the exponent. So otherwise you can expand it in that manner. So now I'm going to apply that law. Let's see. There, I'm just expanding, guys. I'm just separating those. Then multiplied by 2 to the exponent 4. This is still the same as that. Multiplied by 3 to the exponent 2n multiplied by 2 to the exponent. It separates with its original sign. The whole of that divided by, let's see if we say 3 to the exponent 2n multiplied by 2 to the exponent 3n as it is. You cannot separate those. You can, but in this case there's no need to separate because you are most interested in having the base as its lowest number, which you did. From there you had that, there you had 4, there you had that. That's why that 2 throughout you've been writing it as it is. So you are now at that stage where you separate the exponents. That's why at this stage you can now say 2 to the exponent 1 multiplied by 2 to the exponent negative n. So guys, remember, there are different ways in which you can approach this type of problems. So it doesn't really matter that much in terms of which approach you use, but what matters the most is for you to play around those rules. So let's see. I think there's that 3 to the exponent 2n which can cancel each other out. And again, what else? Or maybe let me write what is remaining. So we remain with 2 to the exponent 2n. Remember, we've got a negative exponent over there, which we're going to then bring it to the top so that we've got a positive exponent. So I can just write it closer to that n over there and say I've got 2 to the exponent positive n. Remember, I still have this 2. So I'm going to write 2 to the exponent positive 4. But this one, guys, I'm going to bring it to the bottom as a positive exponent, which means I'm going to have, let's see, that one which is 2 to the exponent 3n. What else do I have? I still have that 2 over there. Remember, I said I'm going to move that one to the bottom and write it as a positive exponent. Guys, before I further simplify this, does it make sense? Whatever that I'm explaining, guys, does it make sense up to this point?
Yes, sir.
Second confirmation.
Yes, sir.
Okay, now that you say it makes sense, let me further simplify that, ladies and gentlemen. That means, let's see what else we are having. So now can you see, you are going back to that rule where you say you've got the same basis. So if you've got the same basis, work out the like terms. So that means you've got 2, which is that 2 and that 2. You can say 2n, you plus that n over there. So you multiplied by 2 to the exponent 4. So you don't want to add 4 there because there you just want to group the like terms of n. At the bottom, let's see what's going on down there. So we've got 2 to the exponent 3n. So now you can do the same as you did at the top, but now you'll be doing with the numbers. So which means it's going to be 2, which is that 2 and that 2. Remember, you've got an invisible 1 over there. Then it's going to be 1 plus 2, which is that 2 over there. This is equals to 2n plus n. So it's that base. Then you've got 3n multiplied by 2 to the exponent 4 divided by 2 to the exponent 3n multiplied by 2 to the exponent 3. Ladies and gentlemen, I'm not sure if you're able to notice that you can cancel those two because they are the same at the top and at the bottom. That means you remain with 2 to the exponent 4 over 2 to the exponent 3. Remember, guys, with this type of questions, that's when they say simplify without using a calculator. So they are simply saying do not punch the whole of this and give a final answer. No, use the laws to solve that without using a calculator, which means we've got the same basis, guys. We can just write the same base. Remember, we've got a division, which means we say 4 minus that 3 over there. What is that? It's 2 to the exponent 1. What is that? This is the same as 2. So guys, I'm not sure if you are able to see or you saw everything that I've written over there. Any indication if that makes sense, guys?
Yes, sir.
Second confirmation.
Yes, sir.
100%. Most of you will remember that I said there's a way in which I prove if my expression or whatever that, I mean, my simplification is correct. So that final answer, if it's a number, I usually substitute it from the original equation where I see n. So that means in place of n, punch on a calculator, I substitute 2 and say that over there, then you're going to multiply 9 to the exponent. You substitute 2 where you see n, you minus 1 divided by 72 to the exponent. You substitute 2 wherever you see n, you multiply it by 2 to the exponent 1 minus into 2. So the whole of this, when you punch on a calculator, it must give you 2. If it doesn't give you 2, it's either you punched incorrectly there, or otherwise it's an indication that your calculation is wrong. So can you guys substitute all of that and let me know if you're getting 2?
So it's not 2.
It's not 2.
Yes.
Someone else to check if you're not getting 2.
So it's not 2.
100%. Then, if it's not 2 and both of you confirmed to say it's not 2, then it means somewhere, somehow, you made a mistake when you were doing your calculation, which means we might need to try and visit our calculations. Remember, guys, as I've indicated from my previous lessons, there's a value in each and every mistake being done, because if you do this mistake in your exam, you are able to quickly try to retrace and check where you could have made a mistake. Assuming that I was in exam, then the first thing that you do, guys, in case if you find an answer which doesn't make any sense, the very first thing that you need to do is to check if you copied the problem correctly. Let's check. All of that has been copied correctly. Then you can start trying to check where you could have made a mistake. So on that step, that is 4. Yes, is that 4? This is 9. Yes, 3 squared, 2 cubed. Yes, is 17. That then n. This is as it is. Then let's check over there. So is that times that is 2n, that times that is 4, and then that times that is 2n, that times that is 2. Yes. Then at the bottom, we've got 3 to the exponent 2n, yes, 2 to the exponent 3n, yes, then that you just write it as it is. Then now, let's see, we expand. We've got 2 to the exponent that, yes, 2 to the exponent 4, yes, then we've got 3 to the exponent 2n, yes, then what else? What else? Okay, yeah. Can you see now, guys? Can you see where we made a mistake? There, it is not supposed to be 2, guys. Can someone tell us why it is not supposed to be 2?
So it's supposed to be 3 raised to the power negative 2.
Ladies and gentlemen, this is how you detect a mistake. Just in case if you are in exam and you try to prove if your answer is wrong or correct, and you don't find the correct answer, then it helps you to quickly try to check how that mistake came about. So that means if this question or this problem was allocated, let's say 5 marks, there's a possibility that you can score a mark there and you lose 3 marks, because from this step going down, almost everything is wrong. That's why we're even getting a wrong answer. So guys, which means I'm going to give you this as your homework, where you need to correct that mistake over there and write 3, then apply everything that I've been explaining until you get to the right answer. Ladies and gentlemen, if you get as an example, I'm trying to think, let's say for example you get 8/9 as your final answer, as you simplify the whole of this, substitute it there just like you did when you said it's not giving you 2. Substitute it there. And when you punch the whole of that, it must give you that 8 over 9. Guys, you know very well that there's a reason why I'm giving you this homework. Remember, guys, not everyone in this group will remain in this group until June exams, final exams, or whatever. So I make use of this type of lessons to see who needs to stay until the end of the year. So, ladies and gentlemen, do we agree that this is your homework?
Yes, sir.
Yes, I agreed.
100%. So now we are going to quickly move to the next problem. So I might not fully answer these questions because I see we have spent more time on this lesson. But most importantly, guys, I'll just copy that is 2 to the exponent that by that plus 2 to the exponent that minus 1. This is equals to 5. We know what type of a problem is this, and we've explained everything. So guys, when you solve for x and you're given this, check, is this in its smallest base? Is this in its smallest base? If an answer is a yes, then start expanding, which means you've got 2 to the exponent that one over there plus 2 to the exponent that multiplied by 2 to the exponent negative 1 is equals to 5. And you see, you've just expanded that and that. Why did you have to expand? It's because you notice you might come out with a common factor, which you can take out as 2 to the exponent that. Then you've got 2 to the exponent 1. You've got a positive sign over there. Then you've got 2 to the exponent negative 1, which is equals to 5. And you see, punch the whole of this, guys, and check what it gives you. Remember, you cannot say this is 2 to the exponent 1 minus 1 because in between you do not have a multiplication sign. You've got a positive sign. Also, if it's a negative there, you cannot say you are applying that rule. That is what most of the learners do. From that, they are going to say the bases are the same and therefore add the exponents. That's what the examiner wants to test. If you understand that if you've got a positive sign there, you are not tempted to add the exponents, but you're going to expand, take out a common factor, and then work out this inside the bracket. So let's see. To me, this is 2 plus 1 over 2. So it's more like 2.5. What is 2.5? I think it's 5 over 2. Can someone just confirm if this is the same as 5 over 2, which is equals to 5? So remember, guys, this thing can still be written as 5 over 2 close multiplied by 2 to the exponent 5, which is equals to that. So I want you to notice something. Trias, we've got a coefficient over there which we need to remove because we want to remove everything attached or associated to that 2x squared. So you are going to divide by 5 over 2. Why? Because you want it to remove or you want to cancel it out. Remember, what you do on the left, you also do on the right. So you just punch the whole of that on your calculator. Not really sure what you get, but it's 5 divided by 5 over 2, which is 2. So that means you've got 2 to the exponent x, which is equals to 2. Remember, you've got an invisible 1 over there. Now that the bases are the same, they fall away, which means you can equate the exponents, which means x is equals to 1. So can you see?
Sir,
A question?
it's 1 over 2.
Which one is 1 over 2, Lerato?
On the right hand side, sir.
Which one? This one? Or when you punch this, you're getting a 1 over 2.
Yes, sir.
Is it everyone who's getting 1 over 2? I'm not sure, guys. Let's see. over 5 at the bottom. It's 5 divided by 2. I'm still getting 2, Lerato. That means
I'm also
you
getting
made a
2.
mistake. Yeah. So, Lerato, this is how you punch it on a calculator. So you punch 5. If you do that fraction button, then you must open bracket and say 5 over 2. You must punch it this way. Or otherwise, you must say 5 divided by. Then you say 5 over 2. Try to punch it this way and check if you get 2. And again, if there's someone on the line, try also to check who else is on the line. There's Tia. The other one is Nielin. Guys, are you also getting 2?
Yes, sir.
Okay, so Lerato, that means you need to be very, very careful when you punch on the calculator. Otherwise, if you punch in correctly, you won't find the same answer. Let me see. Maybe you said 2 divided by that divided by that. Yes, you see, that means you said 5, you punched that division sign, and then you said 5, that same division sign, and then you punched 2. That's why you're getting 1 over 2. Can you see? So, when you punch on a calculator, always, or in most cases, use a fraction button, guys. You will never go wrong. Say 5 fraction button into 5 divided by 2, or in a fraction button 2. So that means if you substitute 1 there, 1 there, and punch the whole of this, what are you supposed to get, Shreyas?
Sir, say again, please.
If you see that our x value is equals to 1, isn't it?
Yes, sir.
So when you substitute 1 where you see x in the original equation
So it gives
and
you
punch the
5,
whole
sir.
of that, so it has to give you 5. So that's how you prove if your final answer is correct. You must say 2 to the exponent 1 plus 1 at the bottom plus 2 to the exponent 1 minus 1. It must give you 5. So I can easily show you that one by means of calculations. So remember, guys, 2 to the exponent 1 plus 1 plus 2 to the exponent 1 minus 1. You know this is a 2 squared plus this is 2 to the exponent 0. Then this is 4 plus the whole of this is 1. 4 plus 1 is equals to 5. So ladies and gentlemen, I hope you fully understood that part. So what I'm going to do now is just to quickly explain to you how you can work out these two problems. So remember, guys, what is that? That is an equation. What type of an equation? A quadratic equation. Why? Because of that squared, it makes it a quadratic equation, which means you need to rewrite it in the standard form of that form, and everything must be equated to 0. Once it's in that form, you need to factorize. Equate it to 0, then solve for the value of x. And obviously, you're going to have two values of x. Shreyas, this is your homework where I need you to factorize that using your head the same way we um, the same way we did on yesterday's lesson, where you multiply that a by the c value and try to find two values which can give you the middle term, and then from there work out or take out the common factor and factorize that, then solve for x. And for everyone else, you can use any possible method to solve for the value of x. This type of problem is normally given 3 marks. I'll just do for you that number 4. So that number 4, guys, let's see. What are you having over there? You can see you've got the same basis over there. you've got the same basis over there. And again, you are multiplying those numbers. So this could be 2 to the exponent 1 multiplied by 3 to the exponent 1 multiplied by a to the exponent 2. Because the bases are the same, you can add the exponents. Multiplied by, remember, anything to the exponent 0 is equals to 1. Very, very much important, ladies and gentlemen. 2 times 3. You cannot say whatever, then you add the exponents because the bases are not the same. So you say 2 times 3, this is 6. 6 times that 1 is the same as just 6. Then you've got a to the exponent that plus that is 5. Guys, did that make sense or was I too fast?
No, sir, it made sense, sir.
It makes sense, ne?
Yes, sir.
The other guys, are you happy? Lerato, Nilin, are you guys happy? Did everything make sense to you?
Yes, sir.
Is this one I didn't understand? Can
So
you
you
please
mean
come
which one?
again?
The last one? Okay, let me quickly explain that one. So you've got 2a squared multiplied by 3a to the exponent 3 multiplied by b to the exponent 0. So I'm going to rewrite that in the order where I start with the numbers, letters, and follow alphabetical order. So I've got 2, which is that 2. I know it's multiplying that 3. So I can say multiplied by 3 multiplied by that a, which is that a there with a squared, multiplied by a, which is that a with cubed. Then after a, you know what comes is letter b. So now I've just rearranged it in order. So 2 multiplied by 3 is 6. Then you've got that a and that a, which means the bases are the same. You can add the exponents. Therefore, it's 2 plus 3 multiplied by, I've said anything to the exponent 0 is 1, which means it's now 6 multiplied by 1, which is the same as 6 multiplied by a. Then you add the exponents. Then you've got 5 over there. So you cannot further simplify that. It ends there. Nilin, I'm not sure if it now makes sense.
Yeah, I understand now.
So guys, I hope you've gained a lot out of this lesson. What I'm going to do, I'm going to send in the group additional type of problems that you can use just to practice. It's not your homework. You can just use for practicing purposes. So I think our next lesson might be sometime over the weekend. For tomorrow, there won't be a lesson. But what I would like for you to do is to send whatever homework that I've given to you. So if you happen to have a spare time, just try to work it out. Do not copy, make those mistakes so that I'm able to know and notice the type of mistakes that you are most likely to do, so that on my next lesson, I can address those mistakes to better everyone. Because when you make those lot of different mistakes, we all benefit in each other's mistakes. So guys, this brings us to the end of our lesson for today, and I hope you enjoyed this lesson as much as I did. So guys, this is that time where I need to sign out. Remember guys, I'm going to post this lesson and also share the link. So guys, have a good night and thanks very much for joining.
Thank you, sir. You too.
Yeah, thank you. Good night.
Thanks, man.